fourth and final recording for week number 2. Now we're going to go Roman numeral 3, which I read before, but I'll go over again. Let's say that it says this particular problem number 1, we've got the scores 2, 3, and 4, and 1, 3, and 5. But now let us say that instead of saying I have only 3 people in each of those classes, which really wouldn't typically be the case, let's say that I got those 3 scores and they were from a class of 20 students at Mary Baldwin and 20 students at JMU. Everybody heard about my great reputation for teaching, so they decided they wanted to take my class. So we had 20 students in each one. Not that I've taught a class actually at JMU. But anyway, so one of the questions we have to ask here, and the first one is, how is this problem now different than problem number 1? Well, hopefully you would be able to answer that in problem number 1, when I presented that there were only 3 people in each class, that I was dealing with a population there. And whenever you deal with a population, you use Greek symbols, mu, sigma, so forth. Sigma is for the standard deviation, that we use Greek letters when it's from a population, because that means you have all the scores from that particular group. When it's the problem 3 here, when it's 3 scores out of 20, now you're dealing with a sample. And in statistics, whenever we deal with a sample, we use alphabetic characters, X's and X bars, and we don't use any Greek symbols. So one of the big differences is in terms of the symbols, and you can see my funny little statement there. It is Greek to me. I hate Greek. Can we just stick with the alphabet? So if you're dealing with a population where you actually have everybody in the group you want to study, then you use Greek letters. And if you're actually using a sample, which is most often the case, then you have to use alphabetic characters. So that's one of the differences. So a sample is different than a population. Variability. There's really no difference in terms of measuring central tendency, except if you're dealing with a sample, you use X bar. If you're dealing with a population, you use mu, which is Greek. But variability is a little bit different. And if you get a little confused on this the first time, don't worry, it's okay. And I'll try to explain it a couple of times, and then when we meet for class, go over it again. But variability. Sums of squares, when you're dealing with a sample versus a population, it's the same. So the sums of squares are the same. And if you look at the 3 scores in each group, the dispersion in those 2 groups is exactly the same. The sums of squares for the first 3 numbers, 2, 3, and 4, any 3 consecutive numbers, the sums of squares are 2. For the second group, the 1, 3, and 5, with the JMU data, if it's alternative numbers, then it's sums of squares of, what did we say, 8 there, 1 minus 3, so the sums of squares are 8. So if you're dealing with a sample versus a population, there's no difference in terms of the sums of squares. But there is a big difference in terms of variance. Remember, we like to use variance, especially when they're different sample sizes. Remember, if this is a population, what would be the variance for each one of these? Well, if it was really from a population, 2, 3, and 4, the variance would be what? Well, the sums of squares would be 2. It would be 2 over 3, so 0.67. If it was a population for the other group, 1, 3, and 5, then it would be the sums of squares 8 divided by 2, so the sums of squares would be, the variance would be 4 for that. So that's the issue if we're using a population, but we said this is a sample. So the formula is just a little different. I think it would be best if I explain the little difference in the formula first, and then try to explain the logic behind it after, which is our last big thing. The formula, if you look on the agenda, for variance, when you're using a sample, is to take the sums of squares and now not divide it by n, but n minus 1. So if you were to do that with the 2, 3, and 4, the sums of squares there is what? 2. And if you were to use the formula for the sample variance, then it would be 2 divided by 2. So the variance would be 1, and so would the standard deviation. For the second group, 1, 3, and 5, the sums of squares are what? The sums of squares are 8. You would divide that now not by 3, but by 2. So you'd get the variance equal to 4 and the standard deviation equal to 2. So in this particular situation, if you're dealing with a sample, you actually have to do this n minus 1 thing, and hopefully it's a pretty simple computation, and you do that for the variance, and then you just take the square root to get the standard deviation. So the final thing I'm going to try to do is explain why this is done. And hopefully page 114 of your book can try to explain this a bit. If you've got version 9, as the case may be. So let me just try to share with you the logic behind this, and there won't be any computations here. The logic behind this. If you're working with a group of 20 people, and you want to know their attitudinal scale, or their attitudinal score, or something else, even their height or their weight, and you just get 3 people from that group, where would you tend to get the numbers for that group? Most people would argue if you want to know people's attitudinal score and you got 20 people in the class, you could have a whole host of different possible scores, but when you sample 3 people, you're going to tend to get people kind of in the middle. You're going to tend to get people in the middle of the distribution. And so what statisticians often think is that if you only get 3 people out of 20, you're going to tend to miss the extremes when you sample only 3 people out of 20. And because you're only sampling in the middle, you're underestimating the dispersion of that sample. You've got 3 people in the sample. It's 3 out of 20. You're really trying to figure out something about the population, but if you only have 3 people, you'll tend to get numbers towards the middle. So when we get a sample, we tend to underestimate the true population variability. And so what statisticians decide to do about that is they make that correction that you see, that n minus 1. So they try to correct for that, and they do this n minus 1 thing. If you look on page 114, it says a sample tends to underestimate the population parameters. So we do this n minus 1 thing, which tends to make the dispersion higher for a sample than it does for a population. So if you have the scores, 1, 2, and 3, and the 1, 2, and 3 come from a population, you say, well, the variance is 2/3. But if those 3 numbers, 1, 2, and 3, come from a sample that represents a population, you're going to say, well, those numbers are really underestimating the true population variance. So I'm going to make a little edit to the correction, try to fix for that bias because the sample underestimates population variance. So I'll take the numbers of 1, 2, and 3, and I'll get a sums of squares of 2. And now for the variance, instead of dividing 2 over 3, I'll divide 2 by 2, and I'll get a variance of 1. 1 says there's more dispersion than 0.67, or 2/3. So hopefully you understand this. If you do, that's great. If you don't lose too much sleep over it. But the reason that we actually work with this n minus 1 thing for a sample is we're trying to correct for the fact that when we take a sample, we're usually underestimating population dispersion. So we do this n minus 1, which makes the sample variance and standard D a little bit bigger than they normally would be. So that's a correction. So hopefully this makes sense. Let me get to the final thing here, the homework. We've got 2 problems for you. I would expect that you would take some really good notes on this information so that if you ever had to come back to it, you would have the key information. Type them up into a Word file probably. You'll get some points for the notes, and then the 2 homework problems will really show competency with these ideas. 5 sophomores majoring in psych, so it gives you a different data set. See if you can compute and answer the question, which group has more confidence and which group shows more dispersion in their answers. So make sure you do all the math here, but at the same time make sure you answer the 2 key questions. Then homework problem 1B, if it's 5 sophomores from each institution and they were a small group representing the total number, explain how that data is different, and then what you would do with this. So if you can take good notes and have good information, send me drafts up till Saturday if you wish, and then post. Come to class on, what is it, Monday, is it June the 9th, with questions. We will cover this, a little new information, and a review before your test the following week. So good luck, everybody, and I hope this makes sense. Bye-bye.